1.
Good afternoon, fellow educators. Today I want to talk to you about using the 7 cross-cutting concepts in STEM education. Using cross-cutting concepts in STEM education helps our students develop an understanding of scientific concepts and fosters a framework for how to use science and engineering in everyday life. Cross-cutting concepts allow students to engage in scientific reasoning, which in turn helps students build a scientifically based understanding of the world around them. To better assess the cross-cutting concepts, teachers can encourage classroom discourse and ask questions that prompt students to use the 7 cross-cutting concepts to explain their work. When using the cross-cutting concepts, we can support diverse learners. For example, our gifted students can be given more complex scientific problems to understand and solve. For students with learning disabilities, STEM lessons provide visual and auditory access, as well as having technology integrated into the framework. The 7 cross-cutting concepts, as I've shown here, are patterns, cause and effect, scale, proportion and quality, systems and system model, energy and matter, structure and function, stability and change. For patterns, questions about relationships of observed patterns of forms and events guide organization. For cause and effect, events have simple, complex causes. Science investigates the relationship and evaluates the context. For scale, proportion, and quantity, during an occurrence, an understanding of what matter, at what scale, proportion, and energy level, or changes in quantity impact the structure or function of the system. For system and system model, explaining the system being studied, establishing its boundaries, and developing a model to help understand the system. Energy and matter, the monitoring of the flow of matter into and out of a system, and energy helps in the understanding of potential and constraints of a system. For structure and function, functions and characteristics of a living creature or object are determined by its shapes and properties. And finally, we have stability and change. A system's pace of change is determined by stability conditions and influencing factors for both natural and artificial systems. By integrating these into our teaching, we will help our students understand the world around them. Thank you.